Right. The first question is explain the meaning of the term diffraction. Diffraction is the spreading out of paths after passing through a gap or around an obstacle. The next question is state the condition necessary for electrons to produce observable diffraction when passing through matter. This condition is that electrons must behave as waves, and the spacing of the gaps in the material need to be around the wavelength of the electron. The next question is show that the speed of an electron with a de Broglie wavelength of 1.2 times 10 to the minus 10 meters is 6.0 times 10 to the 6 meters per second. For this, you use your equation lambda equals h over mv, and by rearranging for v, you get v equals h over lambda m. Then you input your values. H is Planck's constant, which is 6.63 times 10 to the minus 34 over the de Broglie wavelength of this electron, which is 1.2 times 10 to the minus 10 multiplied by the mass of an electron, which is 9.11 times 10 to the minus 31, which gives you, well, around 6.0 times 10 to the 6 meters per second. For this next question, you're given that an electron is accelerated to the speed of 6 times 10 to the 6 meters per second using an electron gun like this. You're told to calculate the potential difference supplied by this DC supply to accelerate the electron to this speed. For this, you use EV equals a half mv squared, which is just another way of writing the conservation of energy, and you're going to rearrange for V. Once you've got this, you just put in your values. Which gives you the answer of 1.02 times 10 to the 2 volts. The last question is suggest why in an electron gun the cathode is connected to the negative terminal of the supply rather than the positive terminal. The answer is that the electrons need to be repelled by the cathode and attracted towards the anode for the electron gun to work. I'll do.